Got this? Multiple, still linear regression. Multiple, it means more than one predictor. All right, multiple, more than one predictor. So multiple linear regression. So simple linear regression, y quantitative and 1x. But I can see quantitative is a dependent variable, 1 versus several, more than one independent variables, right? One dependent and many independent. So like x1, x2 until xp. The equation for simple linear regression only until here. Only until here. So multiple, we add more variables. More independent variables will be added. That's only difference now. See there? Right. So basically you want to know, we write the equation y equals to b naught, there's a constant, b1, the slope for x1, b2, slope for x2, and so on. The objective is to test whether these values are they 0 or non-zero, right? So example, let's say y equals to x1, x2, x3. So b1, b2, b3 are the slopes for x1, x2, x3. Now, if b1 more than 0, if b1, b2, 0, b3 absolute value not 0. So in this case, if b2 is 0, the graph for x2 and y will look like that, flat, right? That means y does not depend on x2. If b2 is not 0, then it say y depends on x1. Since the value is positive, it's increasing. Here, again, absolute value is more than 0, it's negative. Y depends on x1. We say the higher the x1, the lower. So what I'm looking for is, are the slopes 0 and non-zero? How do you know 0, non-zero? We look at the p-value. We look at the p-value for the variables, p-value for x1, x2, x3. If the p-value is less than 0.05, then the b is not 0. If the p-value is more than 0.05, then the graph is flat, b2 0, then y does not depend on x1. That's how we're going to interpret, right? Imagine this equation. These x1, x2, x3 are independent variables. b1, b2, b3 are the slopes. We want to know, are they 0 or not 0? The p-value is more than 0.05, then it says 0. P-value less than 0.05, then it says is not 0. Then it says y depends on it, right? Assumptions. You did seen this assumption earlier for simple linear regression. The error terms, the residuals, must be independent and normally distributed. Now we have one more added assumption. All the x1, x2, whatever the x, must be independent of each other. Independent. If they're not independent, there is a problem of multi-collinearity. Multi-collinearity. That means some x's are very highly correlated. Right? Later we'll see how to check this. So in addition to the assumption we talked about last week, we're going to add one more assumption. Right? That's multi-collinearity. So how to check multi-collinearity? Just ignore the others. Rule of thumb. We're going to ask for this particular statistics VIF. So what's VIF? Variance, inflation, factor. Later, one click, SPSS gives you the value of VIF and interpret according to this. VIF less than 5, no serious problem. VIF 5 to 10, substantial problem. More than 10, serious problem. In our class, anything more than 5, we're going to say there's a problem. Anything more than 5, we're going to assume there is a problem. Then you want to go and see where the problem lies. Right? So that's multipolarity. Okay? Example. To test the association between age, weight, BSA, height, and BP. Earlier, we only talked about last week, only 2 variables. Example, BP and BMI. So now we added more variables. Then it's called multiple linear regression. So look at the variables now. We're going to connect the SBP with these variables. All right. Again, 3 steps: scatter, correlate, and regression. So follow this instruction. You add these variables into this and click OK. So that's a graph will come out. You're going to take half the graph, right? Below this, because it's a mirror image. This is same as that. This is same as that. So take the half the cut. Okay, now we can see this is BP, this age. So this graph is BP versus age. It's quite linear. Weight versus BP, also linear. BSA versus BP, also linear. Waist, BP, also linear. So it looks like there is an association between BP, age, BP, weight, BP, BSA, BP, and waist. Now, look at this graph. This graph is between weight, and BSA. The graph is BSA is body surface area. Body surface area.
Excuse me, Professor.
Sure.
If I try it again, can you let her in?
But still cannot. She doesn't come in.
She have restart the computer.
Is she in now?
Yeah, she tried the 3rd time.
Okay, is she in now? Verify, right?
Yeah, she's in.
Okay, good.
Thank you. Sorry.
Right. So I just covered this side, just comparing BP and age, BP and weight, BP BSA, BP waist. All the patterns are positive. Now this among the independent variables, BSA and weight, very linear. Higher the weight, higher the BSA. Imagine elephant, very big, very skin. The skin area is very large. BSA is body surface area, right? So it looks like there could be a problem of multipolarity, because it looks like weight and BSA are not independent, highly correlated. And then go to correlation. We put all the variables in. Click OK. So that's a table now. Let's start with BP first. Look at BP. BP versus age. Right? This BP versus weight, BSA, and waist. Again, you can cover the half, just concentrate here. So looking at this now, BP, look at the p-values for all are less than 0.05. And all the values are more than 0.3. So pairwise meaning BP and age, BP and weight, BP and BSA, BP and waist. They're all highly correlated. Look at this now. All the correlations are high. So all are significant. Remember, this is only pairwise. Now look at this now. BSA versus weight, right? BSA versus weight. So this value is 0.938. It's very high. Any values more than 0.9 will lead to a problem of multipolarity. So can't confirm yet, but we know that this value is very significant, very high. There could be a problem of multicollinearity. So now, so far, the assumptions are the variables must be independent. Looks like based on this, they are not BSA and weight. And also the correlation is very high. There could be a problem of multicollinearity. Later we'll see how to quantify this, right? So next we move into regression. Regression, so now I must decide what's the dependence BP, independent, all these variables. For time being, click OK. Right. So now we have three tables. My objective is what's the association between BP and these variables. So look at the NOR table, as we did last week. Look at the p-value. So this p-value less than 0.05. So our interpretation is SBP depends on at least one of the four. I'm not telling BP depends on all this. SBP depends on at least one of the four predictors. What's the next question? What's the next question? BP depends on at least one of the predictors. What's the next question?
Which predictor?
Which one? Which one? Depends on at least one. Next question. Which one? Look at this table. Coefficients table. Look at the last column. The p-value for all the various significant except for BSA. That don't say BP depends on all the four. Here we say depends on at least one of the four. Which one? All except for BSA. Age, weight, and waist only. And then step number 3, write the equation. Because BSA is not significant, you can't drop this in writing the equation. They still must be in the equation. Even though not significant, from this table, we write the equation, so all the values must be there. Interpretation. Example for age. Every unit increase in age, BP expected to increase by 0.684 units, provided the other variables remain unchanged. Example, the weight, BSA, and waist. For a person 40 years old, become 41. 40 to 41, 1 unit increase in age. BP expected to increase by 0.6848 units, provided the other variables remain unchanged. Okay. All right. Okay. So 1, does BP depend on these variables? Yes, at least 1. Which one? This table, all except for BSA. Write the equation and interpret. Next, number 5, R squared is how much? R squared. R squared is 0.636. That means 63.6% of variation in BP is explained by these 4 variables. Right here, even though BSA is not significant, you must say all the 4 variables. So the results comes out. Look at 3 tables there. First table, my objective is, does BP depend on waist, BSA, age, and weight? P-value less than 0.05. Yes, at least 1. Which one? You look at the p-value, right? Except for BSA. How? Write the equation. You want to explain this coefficient? That's how you explain that how much? R squared. explained by the 4 predictors. Next, we have the assumptions. So what's the assumption? Testing multicollinearity. We redo regression. Later we'll see how it's done. Select statistics and check this box, co-linearity diagnosis. And click OK. Now one more additional column. Variance inflation factor, we have additional column. Look at the first value. This is less than 5. This is more than 5. This is more than 5. So there is a problem of multicollinearity. There is a problem. Again, look back of the scatter plot. We could see there could be a problem. From the correlation is very high. There could be a problem. Now, with this testing, is confirmed there is a problem. So we know the problems between weight and BSA. Heavier the person, bigger the body surface area. So there is a problem of multicollinearity. Next, testing the residuals. You're done for linear regression. Always receipt, always predicted, and also save the residuals, as we did earlier for simple linear regression. Look at the diagram for the residual plot. So this is a residual plot. This is predicted. So you can see all the dots are random, right? There's no pattern. That's what you want. So first assumption, their residuals are independent, is met. Second assumption, testing normality. We do the same procedure, plots normality, and select residuals. Look at the p-value. The p-value is more than 0.05. Therefore, assumption is met. Residuals are normally distributed. So out of the 2 assumptions now, multicollinearity is not met. So this model is not valid. It's not valid. Residuals, this is okay, and also normally distributed. So 2 assumptions, residual assumptions met, but not multicollinearity. Therefore, this model is not valid. So then what do you do? You can try this stepwise method. Stepwise method. Stepwise means, after explain what is stepwise, okay? So change this method. Just now was enter method. Pull down the menu, change to stepwise, and then click OK. Right? At the same time, sorry, before this, go to statistics, check R-squared change. Right? Multicollinearity is there. And run. Now look at this first table. Stepwise means what? Dependent variables BP. Independent variables, we have age, weight, waist, and BSA. Model 1 refers to step 1. Step 1, age came in. Next step, step 2, weight comes in. Next step, waist comes in. So 3 of the 4 variables already there. So over and above age, weight, and waist, BMI does not make any difference. So BMI was dropped. Look at this table. The R-squared change. Model 1. So what's model 1? Age. Age alone explains, look at the R-squared change, 46.5%. Age alone explains 46.5%. Next model, model 2, age plus weight. So this R-squared change. This is age alone. This is over and above age, how much explained by the weight. Look at this box here. First model, this is second model. Second model refers to age and weight. So we say age alone explains 46.5%. This one, age and weight explain for 60.7%. Next variable, variable 3, that's weights. Weights explain 3%. So add together 63.6%. So say age alone explain 46, weight add another 14 to make it to 60, weight add another 3, make it 63. So 63% of the variation is explained by the 3 variables. Now compare the entire method, the R square and the entire method. So that's R square with all the 4 variables. R square 63.6% with the 4 variables. Yeah. Again, 63.6% with the 4 variables. So these two are no different. Therefore, BSA does not contribute to the variation. So these 3 variables are sufficient to explain variation in BP. Next, let's see what happened to the VIF. This age alone, age and weight, age, weight, and weight. So look at the last column. Highest value is less than 5. So problem of multicolority has been resolved. So this one way of taking care of multicolority. One way. There are several other ways of doing it. Now write the equation. The last equation. There are 1, 2 only, you take this. If there are 1, 2, 3, 4, 5, take the last one. So last one is model 3. So based on this, we write the equation. You can see in this equation, there's no BSA. So it's been resolved. So this equation is valid because the VIF, there's no multicolority. Right? Reporting. Association between SBP and the selected variables tested using multiple regression analysis. Not tested, that must be tested. The results are shown in table X. Table X, that's by heading. So you copy and paste this particular table. This table is this table. So these values, it will show how it's done. Plus VIF. So you don't need tolerance, just VIF alone. So that table is presented here as interpret. Right? So as shown in table X, SBP was significantly associated with, I don't have to show the ANOVA table because I'm telling here these variables are significant. Right? With age, weight, and weight. The highest VIF value here is 8.511, which is more than 5. Hence, there was a problem of multicolority. First, write the equation. That's the initial equation. Right? R square. You already seen R square was 63.6%, which means 63.6% of the variation in BP was explained by the 4 predictors. Next, stepwise regression. Only age, don't have to show another table. Only age, weight, and weight were significant. And the R square was no different from the current R square. And the residuals, check the residuals. Are they independent, normally distributed? And that's a final equation. So our objective was to test the association between BP and the 4 variables. There was some problem in this model, especially the multicolority. Stepwise regression, resolve the issue. So that's a final equation, right? So don't take final equation, don't just write, remove this and write the rest. No. Look at these values, slightly different from those values. So that is unstandardized coefficients and standardized coefficients. So what's the difference between unstandardized and standardized? We look at this now. Let's say I want to know which is the most important variable: age, weight, BSA, and waste. This looks like the biggest contribution. Actually, it's not true because all these are measured in different units: age in years, weight in kilogram, BSA in centimeter, waste in meter. So you can't compare these values and see which is bigger, which is smaller. So now we have standardized regression. With standardized regression now, all these are unitless. There's no unit. We compare age and BSA, age and BSA. How much more? How many times more? Right? So we compare age and waste. It's about 2 times as important. So this is for relative importance. Contribution of age is almost twice as much as this. So normally we don't write this. We write this for prediction. But for implementation now, which one to start with, we follow the beta. So you can't do anything with age. Second is waste. It's the weight. So you reduce the weight. Next, waste, reduce the weight. And last, only BSA. However, BSA is not significant. The writing equation, just write this. Right? So that is a typical reporting of multiple linear regression. Any questions? Any questions?